If all the nuclear bombs in the world were detonated at the deepest point of the Mariana Trench, would it trigger a world-destroying super tsunami? The answer may not be what you think. The total yield of all the world's nuclear weapons combined is roughly equal to 3 billion tons of TNT. That sounds terrifying enough to blow the world apart. But if the detonation happened in the Mariana Trench, the result would actually be far less dramatic. Because its deepest point is close to 36,000 feet, the water pressure there is about 1,100 times that at sea level. The superheated bubble created by the explosion would be violently compressed by the surrounding seawater, and the energy would be absorbed layer by layer by the massive weight of the ocean. So even if it were really detonated there, the ocean's surface would most likely show only some noticeable disturbance and might not produce the giant tsunami people imagine. The most terrifying thing about it has never been whether it can be blown apart, but that even if humanity threw its most powerful weapons into it, we still might not truly shake it. This is the Mariana Trench, one of the most mysterious deep-sea forbidden zones on Earth. It lies in the Pacific Ocean east of the Philippines, stretching across the seafloor like a gigantic scar. It stretches about 1,584 miles from north to south. Its average width is about 43.5 miles. The most famous part of the trench is called Challenger Deep, with a depth close to 36,000 feet. How extreme is that number? If you flipped Mount Everest upside down and shoved the whole mountain into it, its summit would still be more than 5,000 feet below the ocean's surface. At first, a lot of people might think, isn't it just a deeper part of the ocean? But what is truly terrifying is not just the depth. At the bottom of Challenger Deep, the pressure is like stacking 90 adult elephants onto an area the size of a fingernail. And that force is not coming straight down from above. It is crushing in from every direction at once. An ordinary submersible down there could crumple instantly like a soda can. The human body would stand even less of a chance, with no time to even feel pain before it was all over. But pressure is not the only threat down there. Darkness is the second challenge that truly suffocates you. Sunlight can reach only about 656 feet below the surface, and below that, you enter a world completely cut off from the sun. That is not the darkness of an ordinary night, but an absolute kind of blackness. In the depths of the trench, even artificial light can only illuminate a few dozen feet around you. Any farther than that, and there is nothing. Can you imagine it? Above you is tens of thousands of feet of seawater. In front of you, there is no sense of direction. All around you are unknown forms of life, yet you cannot see them, while they may already be watching you in the dark. That feeling of oppression is more real than any horror movie. By all logic, a place like this should barely be able to support life. And yet, there is not only life here, it has evolved some incredibly bizarre ways to survive. Who could have imagined it? In the darkest and deepest place on Earth, there is not silence and lifelessness, but a vast number of glowing life forms. They do not glow to look beautiful, they glow to stay alive. Take the hatchetfish, for example. Its body is as flat as a blade, and beneath its belly is a row of light-producing organs. When a predator looks up from below, it sees the faint light filtering down from the surface, and the blue glow from the hatchetfish's underside perfectly erases its outline. It is not lighting itself up, it is hiding itself inside the background. This is called counter-illumination camouflage, the deep-sea version of invisibility. There are also some deep-sea jellyfish that are almost transparent most of the time, like a lump of jelly drifting in the ocean. But once they are attacked, they suddenly release a blinding blue light, like throwing a flashbang into the darkness. The predator chasing them will be stunned, and even more brutally, that burst of light may attract even larger predators. And just like that, the hunter becomes the hunted. In the deep sea, light is not just light, it is a weapon, and it is also a trap. But beyond these glowing assassins, there is another kind of creature in the trench that looks utterly bizarre. The most famous example is the blobfish. A lot of people have seen that ugly photo of it collapsed into a lump and think it looks like a melting blob of pink putty. But that is not what it really looks like in the deep sea. The blobfish originally lives thousands of feet below the surface, where it has long adapted to intense pressure. Once humans bring it up, the external pressure suddenly drops, and its body structure collapses. In other words, it was not born looking like that, it only deforms after leaving the deep sea. But what is truly astonishing goes far beyond these strange fish and shrimp. In the depths of the trench, food is incredibly scarce. Vast stretches of the seafloor look like barren, muddy plains, silent as if they belong to another planet. But every now and then, a major event happens that changes the entire ecosystem. For example, a whale fall. After a 40-ton whale dies, its body slowly sinks to the ocean floor. The first to arrive are usually sharks and other large scavengers, and within months they consume most of the soft tissue. After that, worms, snails, bacteria, and other organisms begin taking over the skeleton. The bacteria continue breaking down the material inside the bones, releasing new chemical nutrients that feed even more microbes and small creatures. A single whale carcass can support a small ecosystem for nearly 100 years. In a deep sea with almost no food sources, the death of one whale is like dropping an entire city onto a wasteland. What is even more mind-blowing is that scientists later discovered that life in some parts of the Mariana Trench does not even rely on the sun to survive. Near certain cold seeps and hydrothermal vents, the seafloor constantly releases methane and hydrogen sulfide. These substances are dangerous to humans, but to the microbes and special organisms living there, they are a source of energy. There is a kind of white tube worm with no mouth and no stomach, yet it survives just fine. That is because special bacteria live inside its body, and these bacteria can convert chemicals into energy, which is basically like cooking for it directly. Scientists call this kind of system a chemosynthetic ecosystem. This means life does not necessarily have to depend on sunlight, and that fact has pushed humanity's imagination about extraterrestrial life much further forward. For so many years, humanity has searched desperately for extraterrestrial life. And yet the breakthrough may not be in the sky at all, but in the deepest part of Earth's oceans. The life forms here are redefining the very conditions required for life to exist. Because inside icy worlds like Europa and Titan, there may also be vast hidden oceans. If life can emerge in the darkest depths of Earth's ocean without relying on sunlight, then why couldn't it happen on other worlds too? And that is exactly why the value of the Mariana Trench has never been just about its depth. It is more like a key, one that may point to the origin of life, and perhaps even to the answer to extraterrestrial life. Humanity's understanding of this trench did not begin all that long ago. In 1875, the British research vessel Challenger arrived in the waters near Guam. Its crew lowered a sounding line with a lead weight down toward the seafloor. But even after reaching about 26,850 feet, it still had not touched bottom. Everyone realized that an astonishing abyss lay beneath them. It was not until 1951 that Challenger 2 returned to the area and used sonar equipment to map out the trench more clearly. Scientists then confirmed that at the southern end, there was an extremely deep region exceeding 36,000 feet, which was later named Challenger Deep. On January 23, 1960, Jacques Picard and U.S. Navy Lieutenant Don Walsh descended in the bathyscaphe Trieste, becoming the first people to truly reach the bottom of the trench. During the descent, the vessel's hull kept making strange noises as it was compressed. When they passed about 29,500 feet, a crack even appeared in one of the viewports. But in the end, they still made it to a depth of about 35,800 feet and stayed on the seafloor for 20 minutes. At that moment, humanity truly touched the deepest place on Earth for the first time. For the next 52 years, no one returned there. Not until 2012 did Titanic director James Cameron pilot a one-man submersible alone and descend once again to Challenger Deep, where he remained on the seafloor for about 3 hours. But the one that truly pushed deep-sea exploration into a new phase was China. On November 10, 2020, China's Fenduzhe successfully descended to about 35,790 feet, setting a record for the most researchers to reach Challenger Deep at the same time. Then in 2024, China deployed a deep-sea robot only about the size of a shoebox. It had no pilot, no tether, yet it could carry out its tasks independently and return on its own. That represents something very important. Exploring the deepest ocean is shifting from an adventure for a handful of people into a capability that can be scaled up. Work that once required large manned submersibles may one day be handled by large numbers of small robots, and whoever develops that capability first will gain the advantage in the race for the deep sea. So what exactly are countries hoping to gain by rushing into the deep sea? First, there is combustible ice, also known as methane hydrate. Its reserves are enormous, and its total energy content may even exceed that of all traditional oil, natural gas, and coal combined. Whoever first masters stable extraction technology may hold the initiative in the next generation of energy. Second, there are deep-sea minerals. On the seafloor lie polymetallic nodules rich in manganese, nickel, copper, and cobalt. These are all critical raw materials for batteries and the new energy industry. On an even larger level, the deep sea itself is a strategic domain. Today, when you send messages, watch videos, or transfer money, a huge amount of data is actually transmitted through undersea cables. Millions of kilometers of communication cables lie across the ocean floor worldwide. If key routes are damaged, many of the systems modern society depends on would be hit hard. So when countries explore the Mariana Trench, on the surface it looks like scientific research, but underneath it is also a competition for resources, technology, and strategic power. But that is exactly where the problem lies. We still do not even know how many species live there, and so much remains unclear. Yet we have already started eyeing its energy, minerals, and control. The Mariana Trench is not actually that far from us, yet it remains more unfamiliar than Mars. It holds the secrets of how life adapts to extreme environments, and it also holds the deepest measure of humanity's ignorance about this planet. Perhaps what the deep sea offers us has never been just a resource zone. It is more like a mirror. How you choose to treat it reveals what kind of civilization you want to become. Will we conquer first and plunder next, or understand first and approach with care? No one can decide that answer for us. And the Mariana Trench will continue to remain there in silence, waiting for humanity's next approach and waiting to see clearly what choice we will ultimately make.